Good morning, students. Welcome to my YouTube channel, The Tactical Online Academy. This video is for the students who are preparing for the MBBS entrance examination. Today, I am going to give you lecture of the physics in the chapter of vectors and scalars. And in my previous video, I have been giving you the different lessons of the vectors and scalars, and this is the continue of my previous video. So let's start to see the today's lesson. I want to request all the students, please kindly subscribe my channel, like the videos and share through your social media, and also give the necessary comments in the video. And I am planning to provide you the PDF of your course freely. So I want to again request you to subscribe my channel. Thank you. Let's start to study some more lesson of the vectors and scalars chapter. And today I am going to teach you first of all the polygon law of vector. Polygon law of vector states that if a number of vectors are represented in magnitude and direction by sides of a polygon taken in same order, then the resultant C vector of those all the vectors are represented in magnitude and direction by the closing side of the polygon. So the statement looks slightly confusing. I want to explain you again. The polygon law of vector states that if a number of vectors, suppose there are some vectors like A vector, B vector, C vector, D vector, and E vector. Suppose there are 5 vectors are there, and these 5 vectors are represented in magnitude and direction by sides of a polygon that is taken in same order. Then the resultant of these 5 vectors, suppose let's take R vector. The R vector is represented in magnitude and direction by the closing side of the same polygon, like this. Let's see. Suppose here we have a polygon like this. The polygon here, and the polygon has 6 sides, so it is the hexagon. And suppose there are some vectors like A vector is denoted by this side, then B vector is denoted by this side, then C vector is denoted by this side, and D vector is denoted by this side, and E vector is denoted by this side, like this. C. So you can see here A vector, B vector, C vector, D vector, and E vectors are denoted by the sides of this polygon, sides of this hexagon, and taken in same order. You can see the order of the arrow, and all the arrows are in same order. Then in such case, suppose their resultant is R vector, then the resultant R vector is denoted by this remaining closing side, but it is taken in opposite order. See your arrow. The arrow is like this, and it is R vector. So it is the clarification of the polygon law of vector. If a number of vectors, that is A vector, B vector, C vector, D vector, and E vectors, are represented in magnitude and direction by sides of polygon taken in same order, then their resultant can be represented in magnitude and direction by the closing side of the polygon taken in the reverse order, taken in the opposite order. And here in this figure we can write R vector equals to A vector plus B vector plus C vector plus D vector plus E vector. See here. So all these 5 vectors are represented in magnitude and direction by sides of hexagon, 5 sides, 5 sides of hexagon in same order, in same order, then the resultant is represented by the closing side. The resultant is represented by the closing side in reverse order or opposite order. So it is the detail of the polygon law of vector. So I want to again state, if a number of vectors are represented in magnitude and direction by sides of a polygon taken in same order, then the resultant of those vectors can be represented in magnitude and direction by the closing side of the polygon taken in reverse order. So this is the detail of polygon law of vector. Now I am going to teach you parallelogram law of vector. Parallelogram law of vector. And parallelogram law states that if two vectors A vectors and B vectors are represented in magnitude and direction by two sides, two adjacent sides of a parallelogram which are originating from same point. If two vectors A vectors and B vectors are represented in magnitude and direction by two adjacent sides of a parallelogram originating from a same point, then the resultant of the A vector and B vector can be represented in magnitude and direction by the diagonal of the parallelogram which is originating from the same point. So it is parallelogram law of vector. So let's see it detailedly. Suppose we have two vectors, A vectors and B vectors, and A vectors and B vectors are represented in magnitude and direction by two adjacent sides of parallelogram like this, and originating from same point, this point. Then like A, B, CD parallelogram is here, and two vectors. A vector is represented in magnitude and direction by side AD, and B vector is represented in magnitude and direction by side AB. So here you can see A vectors and B vector are represented in magnitude and direction by two adjacent sides of the parallelogram. And then in such case, the resultant of A vector and B vector is represented by a diagonal AC, and it also originated from same point A. So this is the suppose resultant is C vector, then C vector is denoted by AC diagonal, which is originating from point A. So it is the explanation of parallelogram law of vector, and in this case we can write C vector equals to A vector plus B vector. A vector plus B vector. So if two vectors A vectors and B vectors are represented in magnitude and direction by two adjacent sides of a parallelogram originating from same point A, then the resultant of those vectors are represented in magnitude and direction by the diagonal of the parallelogram which is originating from same point A, that is the AC diagonal. So this is the detail of the parallelogram law of vector. Now we are going to discuss sum of vectors. Sum of, suppose we have two vectors, then sum of two vectors, that is A vector and B vector. Let's see how A vector and B vectors can be added. First of all, sum of A vector and B vector is represented by A vector plus B vector. And suppose the angle between those two vectors, A vectors and B vector, is theta, then how will be the sum of the vectors A vectors and B vectors, and what will be the result of this? First of all, the sum of two vectors also is a vector. That means vector is obtained by adding A vector and B vector. So the resultant of A vector and B vector addition is also a vector. So suppose, let's see, suppose we have two vectors like this, A vector and B vector, suppose, and it is like this. Suppose here we have a vector on this side, a vector, and we have another vector b vector, and suppose the angle between a vector and b vector is theta, then what will be the a plus b? Okay. And so for this, first of all, let's draw a parallelogram. Then the resultant of a vector and b vector is the diagonal originating from same point. So this will be the resultant. This you have learned in the parallelogram law of vector. So this will be the resultant vector, and we can denote the resultant vector by r. Now, how is resultant vector r is obtained? And resultant is obtained by the diagonal passing through the same point, diagonal originating from the same point. And suppose this resultant vector makes angle alpha with a vector, and it makes angle beta with b vector. So again, see the diagram carefully. We have a vectors represented by this side of the parallelogram, and we have b vector and represented by this side, and another we have the resultant, which is the diagonal passing through the same point, like a b c d parallelogram, and a b side represent a vector, a d side represent b vector, and a b and a d are two adjacent side, and resultant of a vector and b vector is represented by diagonal AC. An angle between resultant and A vector is alpha. Angle between resultant and B vector is beta. Now in such case, what will be all the formula? Let's see detailedly. First of all, here, resultant R vector equals to A vector plus B vector. So it is from the parallelogram law of vector. R vector equals to A vector plus B vector. Now, uh, let's calculate magnitude of resultant. Magnitude of R vector is obtained by R vector equals to modulus A vector plus B vector. So this is the magnitude of R vector, and it is obtained by this formula. Magnitude of R vector, it is represented like this: magnitude of R vector, and magnitude of R vector equals to it is obtained by this formula, root under a square plus b square plus 2ab cos theta. Now, this is the formula to calculate R vector. So modulus of R vector, magnitude of R vector is obtained by using formula root under a square plus b square plus 2ab cos theta. So this is the magnitude of resultant R vector. So this is the first formula for you. So now the direction of R vector, direction of R vector, direction of resultant. So let's see direction of resultant, and direction of resultant is, in the figure, alpha is angle between angle between angle between R vector, angle between R vector and resultant R vector and A vector, is it or not? So in such case, the direction is obtained by C. It is obtained by alpha equals to tan inverse, it is B sin theta upon A plus B cos theta. I have already shown you in the figure. So alpha is the angle between resultant r vector and a vector. So the formula of alpha is tan inverse b sine theta upon a plus b cos theta. So this is the direction of the resultant, and it is the angle with a vector. So alpha is angle with a vector. Now let's see another formula. Suppose beta is angle between between resultant r vector and b vector. Then in such case, beta equals to, formula is tan inverse, it is a sine theta upon b plus a cos theta. So this is the direction with b vector. So if beta is angle between resultant r vector and b vector, then beta equals to tan inverse a sine theta upon b plus a cos theta. So this is the detail of the direction. So uh, alpha equals to tan inverse, just before I have said you, tan inverse, it is tan inverse b sine theta upon a plus b cos theta. It is the direction with a vector. Okay, this is the direction of resultant with a vector, and beta equals to tan inverse, it is a sine theta upon b plus a cos theta. So this is the direction with b vector. So this is the direction of the resultant r vector. So it is the formula of the direction of the resultant. I think you have understood. So now let's see some special cases in the case of magnitude, and we'll see in the case of direction as well. And first of all, we know the formula of resultant r vector. R vector equals to, you know, I have already said you, resultant r vector equals to root under a square plus b square plus 2ab cos theta. Now we are going to see some special case. Okay? And first special case is, suppose when theta equals to 0 degree. Then when theta equals to 0 degree, then the resultant r vector, here value of cos theta, here cos theta equals to cos 0 degree, and value of cos 0 degree is 1. So this whole part become 1. Then here resultant r vector is obtained to be, it is root under a square plus b square plus 2ab, and a square plus 2ab plus b square, it will be a plus b whole square, and root under a plus b whole square, it will be root under a plus b whole square, it will be square and root is cancelled, and it will be a plus b. So in such case, resultant r vector, in such case when theta equals to 0 degree, then resultant modulus of resultant, magnitude of resultant equals to a plus b, and this is the maximum value. It is the maximum, value of the magnitude of resultant. So when theta equals to 0 degree, then the value of the resultant is maximum. It can be asked in your MBBS entrance examination as well. So when theta equals to 0 degree, resultant r equals to, modulus of resultant r equals to a plus b, and it is the maximum value. Now let's see another case. When First of all, I want to write formula again. You know, formula of magnitude of resultant R equals to same a square plus b square plus 2ab cos theta root under. This is the formula of magnitude of the resultant. Now, when theta equals to 180 degree, then you know cos theta, this part cos theta equals to cos 180 degree, and value of cos 180 degree, it will be equals to -1. So this whole part will be -1. Then you know the resultant R will be a square plus b square minus 2ab. It will be because cos theta will be -1. So let's see. Then here modulus of resultant. It is like this: when theta equals to 180 degree, then the modulus of resultant, magnitude of resultant, it will be, you know, a square plus b square minus 2ab, and you know it will be like a minus b whole square, r equals to root under a minus b whole square, and it will be exactly a minus b. So, and it is the minimum value. It is the minimum value of the magnitude of the resultant. So when theta equals to 180 degree, then value of magnitude of resultant is minimum. So it is the another case. Then now let's see another case when again modulus of resultant equals to, you know, the formula root under a square plus b square plus 2ab cos theta. Now when case is when theta equals to 90 degree, then when theta equals to 90 degree, you know cos theta equals to cos 90 degree, and cos 90 degree equals to 0. So this whole part becomes 0 in such case. Now when this part becomes 0, then more magnitude of r vector resultant will be only a square plus b square. So it is like this: when theta equals to 90 degree, then magnitude of r vector equals to, it is a square plus b square, and it is the medium value of magnitude of resultant. So I want to explain to you the limit of magnitude of r vector is the lowest value is a minus b, or it is b minus a as well. Yes, it is same a minus b or b minus a. So the limit is the lowest value is a minus b is less or equal to the modulus of r vector, and is less or equals to a plus b. It means the magnitude of resultant is minimum. Uh, it is a minus b, and maximum value of the resultant is a plus b, and minimum when theta equals to 180 degree, and maximum when theta equals to 0 degree. So it is the limit of the magnitude of r vector. Now let's you have to know some special case, that is when, you know, in the case of sum of two vectors, when modulus of a vector equals to modulus of b vector and equals to a, then in such case modulus of a vector plus b vector equals to 2a cos theta by 2. It is important point. If modulus of a vector equals to modulus of b vector equals to a, then modulus of a vector plus b vector is obtained 2a cos theta by 2. So it is one point, and I want to say you the another important point, that is if a vector plus b vector, if a vector plus b vector modulus equals to modulus a vector equals to modulus b vector. That means magnitude of two vectors are equal and it is equals to the magnitude of the result, and then in such case then theta equals to 120 degree. This is also important point. So this much I want to explain for today's class, and I'll be coming uh, more remaining lessons of the vectors and scalars chapter in the upcoming videos. Thank you very much.